The Galileo Spacecraft was a mission of breakthroughs, named after the renowned astronomer Galileo Galilei. The Galileo Spacecraft would carry on the future of Jovian exploration. The Galileo Spacecraft was sent to observe Jupiter and its moons. It was launched on October 18, 1989 at the Kennedy Space Center of Florida. NASA used the Atlantis Space Shuttle to get it to space. The primary reason the Galileo was launched was to understand Jupiter in more detail. NASA scientists were very curious of Jupiter and Saturn after the Voyagers explored them. Therefore, they decided to launch the Galileo to explore Jupiter and its moons, and the Cassini-Huygens to explore Saturn and its moons. If you want to know more about the Cassini-Huygens, you can watch my videos on them. The link to those videos are in the description below. To conserve fuel for the Galileo spacecraft, mission scientists decided to take the Galileo to Venus. The reason why was because the Galileo could use Venus as a boost on its way to Jupiter. The Galileo would also use the Earth as a boost 2 times. This method is called a gravity assist. The flight path the Galileo took was called the Vega. V for Venus, 2E for the 2 times the Galileo used Earth as a boost, and GA for gravity assist. Between Mars and Jupiter lies the asteroid belt. On its way to Jupiter, the Galileo went through the asteroid belt and investigated one asteroid called 951 Gaspar, taking many images of the asteroid in 1991. This was the closest observation of an asteroid at the time. The surface area of 951 Gaspar has been found to be around half the size of Hong Kong. The distance of the asteroid belt is really long, and that's why the Galileo spacecraft was still in the asteroid belt in 1993. This also means it could investigate more asteroids. It investigated another asteroid called 243 Ida, and something shocking was discovered. 243 Ida had a moon called a Dactyl. This makes Dactyl the first moon of an asteroid to be discovered. In July of 1994, something stunning was found. A comet called the Shoemaker-Levy 9 was torn apart by Jupiter. Now, most comets orbit the Sun, but this comet orbited Jupiter. What happened was that this comet had come a little too close to Jupiter, and it just smashed into Jupiter. This was stunning because this was the first discovery or the first observation of 2 extraterrestrial objects colliding in the solar system. Right before the Galileo spacecraft reached Jupiter, it deployed a probe called the Jupiter Atmospheric Probe, which would enter the atmosphere of Jupiter. The probe was deployed in July of 1995, to be exact. It finally entered Jupiter's atmosphere on December 7, 1995, the exact same day the Galileo spacecraft reached Jupiter. The probe entered Jupiter's atmosphere at a speed of 106,000 miles per hour. At that speed, it would take less than 15 minutes to travel around the Earth. What was exciting about the Jupiter Atmospheric Probe was that it was the first probe to actually enter the atmosphere of another celestial object in the outer solar system. This was a first of the Galileo mission. The probe slowly melted and vaporized from the intense pressure of Jupiter. Information from the probe gave scientists a new understanding of Jupiter. On that same day, the Galileo spacecraft was captured by Jupiter's gravitational field, making it the first artificial satellite of Jupiter. On June 27, 1996, the Galileo spacecraft came pretty close to Ganymede. Ganymede is the largest moon of Jupiter and the largest moon of the solar system. Ganymede is even larger than Mercury. Ganymede is one of the 4 largest moons of Jupiter, which we call the Galilean moons. We call it that because they were first seen by Galileo Galilei. The 4 moons are Ganymede, Callisto, Io, and Europa, where Ganymede is the largest and Europa is the smallest. During this flyby of Ganymede, the Galileo discovered something shocking. Ganymede had a magnetic field. Now, there's no other moon in our solar system yet discovered to have a magnetic field. Ganymede is the only moon we know in our solar system with a magnetic field. In September of 1996, the Galileo was still close to Ganymede. So mission scientists decided to explore the moon in greater detail. NASA was curious about how Ganymede got a magnetic field. They decided to look at Ganymede's interior to answer their question. It was discovered that Ganymede has a core that is primarily made up of molten iron and nickel. When Ganymede rotates on its axis, the molten iron and nickel in the core rotate. This produces an electric current, which creates a magnetic field. Then we have Callisto. Callisto was the farthest from Jupiter, and the Galileo was crossing Callisto, so mission scientists were like, why not study Callisto? So they studied Callisto. The surface of Callisto is known to be one of the most cratered surfaces in the solar system. It has got a lot of craters. Callisto has a rocky core with ice around it. Evidence from the Galileo supported the theory that Callisto had rock and ice compressed together in its interior. We have 2 more moons left, Europa and Io. The problem with going to Io, however, was that it was too close to Jupiter. This means that high radiation levels at Jupiter could make instruments on the Galileo malfunction. So we left with Europa. So on November 4, 1996, the Galileo explored Europa. Europa, the smallest of the 4 Galilean moons, has an atmosphere made up of oxygen, but it is very thin and weak, so it's not breathable. And then a problem occurred. The Galileo was busy exploring Europa and a solar conjunction happened. A solar conjunction happens when 2 celestial objects happen to be on exact opposite sides of the Sun. One solar conjunction between Earth and Jupiter happened from January 11 to January 28 of 1997, and during that time, the Galileo was exploring Europa. The problem was, the Sun produces a lot of electromagnetic radiation, and this could interfere with signals from the Galileo. Because of this, the Galileo could send really few signals to mission scientists at Earth for the 2.5 weeks of solar conjunction. When the solar conjunction was over, mission scientists decided to continue the exploration of Europa. So that was the primary mission of the Galileo. However, we still had a working spacecraft. It made sense to explore more, so NASA scientists decided to add an extension to the mission called the Galileo Europa mission, or GEM for short. Although you may think that this extension mainly focused on investigating Europa, it also studied other moons of Jupiter, like Io. I will explain about this extension in the part 3 of this series. For now, let's look at the big picture of the primary mission. At Ganymede, discoveries included the discovery of a magnetic field and new understandings of the surface terrain and the internal structure of the moon. At Callisto, discoveries included the composition of the internal structure of the moon and evidence to prove the theory that a salty ocean existed below the moon. At Europa, discoveries included a thin atmosphere and a better understanding of the surface of the moon. So that was the primary mission. If you like this video, make sure to subscribe to us and watch these 2 videos. See you in my next video. Bye!